Hi everyone, how are you all? So today's named reaction is aldol condensation, which is very important as competitive point of view. So in every sequence reaction they will include this aldol condensation, which is very important. In this aldol condensation we are going to see the what is meant by aldol condensation and what is the simple trick we will use for the identifying the product in case of aldol condensation, as well as we will discuss the what type of compounds will participate in aldol condensation and what are the types of aldol condensation, as well as a reaction mechanism for this aldol condensation also we are going to see. So let's get into the video. So now what is aldol condensation here? The aldol condensation is nothing but at least one alpha hydrogen containing aldehydes or ketones will react with a dilute alkali. Okay na? So the strong and dilute alkali it should be, that is what, only 10% of sodium hydroxide we will use. Only 10% of sodium hydroxide in a water we will use. Only 10%. That is, it is a strong base but which we are using as a dilute one. So now this dilute sodium hydroxide, or we can use it as barium hydroxide, or we can use it as sodium carbonate or potassium carbonate also. Metal carbonate also will be act as here the bases, which are considered as bases in case of aldol condensation. Now what happens? At least one alpha hydrogen containing aldehydes or ketones react with this base and forms the beta hydroxy aldehydes or ketones. Those beta hydroxy aldehydes or ketones, aldehydes are said to be aldols. Beta hydroxy ketones are said to be ketones. Now that aldol on condensation upon heating, what happens? We are going to get alpha beta unsaturated aldehyde or ketone will get. So we'll see one by one reaction here. We'll take first reaction. This is acetaldehyde I am taking. So acetaldehyde. So this acetaldehyde contain, this is alpha carbon, carbonyl carbon, adjacent carbon is called alpha carbon. We are taking 2 moles of acetaldehyde. So when it is react with dilute sodium hydroxide, it is what? Dilute sodium hydroxide. Whenever you are seeing this dilute sodium hydroxide with at least one alpha hydrogen, then definitely it is an aldol condensation. Now in this case what happens? Here out of 2 moles of aldehyde, 1 mole of aldehyde will act as electrophile, another mole of aldehyde will act as nucleophile here. So then what happens? We are going to get CH3, CHOH, so CH2, C double bond OH we are getting. So this is alpha carbon, this is beta carbon. So it is beta hydroxy aldehyde. It is what? Beta hydroxy aldehyde. This beta hydroxy aldehyde is called aldol. It is called what? Aldol. So now this aldol on condensation, which is upon heating. So which is upon heating, what happens? By loss of water molecule takes place. Always the double bond will be formed. According to the water, we have to check whether after formation of double bond we have conjugation or not. Now this hydrogen and this OH will be lost as what? Water molecule. That is also possibility. So in between these two hydrogens also, in between these two carbon or in between these two carbon, two possibilities are there, multiple bond. But which multiple bond is more stable? Alpha beta multiple bond is more stable, because which is in conjugation with this carbonyl carbon, carbon to oxygen containing pi bond. So for that reason, in between alpha and beta, you will get the multiple bond CH, this OH, and from this carbon one of the hydrogen is lost, CH, C double bond OH. So it is alpha beta unsaturated compound we are getting. Alpha beta unsaturated aldehyde we are getting. Unsaturated aldehydes we are getting. It is called condensation product. It is called the condensation product. That is what? Aldol condensation. It should have the what? At least one alpha hydrogen. So this is what? Acetaldehyde. When react with dilute sodium hydroxide, we will get the beta hydroxy aldehyde. That beta hydroxy aldehyde is called what? Aldol, which is on condensation. Condensation in the sense, by loss of small quantity of water molecule, small molecule like water or alcohol or hydrogen halides. So from the molecule is said to be what? Condensation. Now here, by loss of small quantity of water will takes place, then we are getting alpha beta unsaturated carbonyl compound. That is what we are calling condensation product. That product is called what? A condensation product. Now we will take the ketone. In case of ketone, you take, it is what? Acetone. This acetone contains 2 alpha hydrogen. So when it is react with dilute base, dilute OH minus ion, then what happens? We are going to get CH3, COH, CH3, CH2, C double bond O, CH3. Now it is what? Alpha carbon, it is beta carbon. So beta hydroxy ketone. Beta hydroxy ketone is called ketol. It is called ketol. So this ketol on condensation upon heating by loss of water molecule takes place, where we will get the double bond here in between these 2 carbon, but not in between these 2 carbon or not in between these 2 carbon, because the double bond which is formed if the terminal double bonds are what? Highly unstable, because it is a less substituted double bond. It is more substituted double bond, and also which is conjugation with this carbonyl oxygen. Okay, so now what happens? CH3, CH3, double bond here, double bond CH, C double bond O, CH3. That is alpha beta unsaturated ketone we are getting. Alpha beta unsaturated ketone. Alpha beta unsaturated ketone. Okay, so now this is actual reaction. So what is the mechanism? What happens? We'll see here. Mechanism we'll see. So first we'll see the mechanism. For in case of acetaldehyde we'll take. Now in case of acetaldehyde, 1 mole of acetaldehyde we are taking. That 1 mole of acetaldehyde I am writing like this. Okay, so here what happens when it is react with base? When it is react with base, then what happens? So this proton H plus ion will be captured by this base, and the bond which is present, which is shifted onto that carbon. So we are getting CH2 minus C double bond O H we are getting. So which is on rearranges to this whatever the negative charge will be shifted here. This oxygen get the negative charge. We are getting CH2 double bond CO minus and H. So it is what we are calling enolate ion. It is enolate ion is the intermediate here in Aldol condensation. Now this is what we are acting. It will act as nucleophile. Enolate ion will act as nucleophile. This enolate ion will attack on the another mole of aldehyde. We have 1 more mole of aldehyde now. So this is another mole of aldehyde. So the enolate ion is what? CH2 double bond CO minus and H. Now here the carbonyl carbon will act as electrophile. It is electrophile. So which is a nucleophile. It is electrophile which is nucleophile. Okay. So simply it is we can write it as electrophile E plus. Now in this case what happens when the negative charge comes here, the pi bond will be attacked on this carbonyl carbon. This oxygen get the negative charge. Then what happens? Whatever the hydrogen ion which it is released here, proton, that proton will be attacked on this carbon, on this oxygen CH3 O minus, it becomes OH. Now here this carbon has the hydrogen. So similarly this CH2 to this carbonyl carbon bond is forming CH2. So C double bond O H. So that is what we are getting aldol. Aldol we are getting beta hydroxy aldehyde we are getting. This beta hydroxy aldehyde on condensation we are getting alpha beta unsaturated compound. Here condensation how it will takes place. This CH2 is there no. I am writing as H. CH. Now this H plus ion and this OH minus ion is removed as water molecule. The bond between this carbon to hydrogen will be shifted on between the alpha beta. Then we will get the CH3 CH double bond CH C double bond OH. So that is what we are calling alpha beta unsaturated compound. Now what we had discussed here in aldol condensation, what happens? 2 moles of aldehydes are reacting with base. Which base? 10% of weak. It is a strong base, but it is in dilute condition. 10% of NaOH or barium hydroxide or sodium carbonate or potassium carbonate. So dilute base, when react with at least one alpha hydrogen containing aldehydes or ketones, then forms the water beta hydroxyaldehyde, and which is on condensation we are going to get alpha beta unsaturated carbonyl compound. Either it may be aldehyde or ketones. Is that clear? What is the intermediate here? Enolate ion. So in some cases they will say carbene anion is the intermediate in case of aldol condensation. Okay, now actually it is an enolate ion will be attack on the 1 another mole of aldehyde. Is that clear? So now we will see the shortcut for this. So what is the shortcut? How you are going to write this reaction? By seeing itself only we can write it. Now you see here we have taken this one now. Now that aldehyde, 2 moles of aldehyde I am taking. So just you write it as CH double bond O. This CH double bond O. This is 1 mole of aldehyde. Another mole of aldehyde is there, no? That CH3 I am writing as, because this alpha carbon, no? Alpha carbon containing 2 hydrogens, I am writing like this: CH2CH, C double bond OH. Just you write whatever the compound they given, you take like this and you write. Now this oxygen and this water is lost as this hydrogen and 2 hydrogen, and this oxygen is lost as water molecule. Then what is left over here? CH3, CH double bond, CH, C double bond OH. So that is alpha beta unsaturated compound. That is condensation product are we getting or not? The final product which we are getting in aldol condensation. Is that clear? Similarly for ketone also you see. So this is CH3, C double bond O, CH3. So this is 1 mole of ketone. So next mole of ketone you take. Next mole of ketone containing alpha hydrogen containing carbon should be written as H2CH. So C double bond O, CH3. Now this H2 and this O will be removed as water molecule, and the leftover one you write as it is. That is CH3, C, CH3 double bond, CH, C double bond O, CH3. Do we got this compound or not? The same compound which we are getting. It is a shortcut, it is a trick, easy to identify the final product in whatever the reaction it may be. Is that clear? So shall we see the next examples here? Which of the following example participate in aldol condensation we will see here. So which compounds will participate in aldol condensation? It must has at least one alpha hydrogen, which has the alpha hydrogen participate in aldol condensation, which also has the alpha hydrogen participate. Now these are alpha carbon, so this 2 contains the alpha hydrogen, but this carbonyl carbon, adjacent carbon is alpha carbon, but which is not having the alpha hydrogen does not participate, which is participate in alpha hydrogen aldol condensation. Here what happens? So which is not having the alpha hydrogen not participate. Now here also not participate because there are no alpha hydrogens. In this case also benzaldehyde also not participate in aldol condensation reaction. Now in this case you see this is alpha carbon, this is also alpha carbon. These carbons are not having any alpha hydrogens, so will not participate in aldol condensation, which is also not participate because there are no alpha hydrogen. Now in this case you see this is carbonyl carbon which has the alpha hydrogen, so it participate in aldol condensation reaction. Is that clear? So next we are going to see the different types of that is cross aldol condensation reaction. Next type of condensation is what? Cross aldol condensation reaction. So which is very important. So cross aldol condensation. Cross aldol condensation reaction. So what is meant by cross aldol condensation here? So we are taken in before this in aldol condensation only same type of aldehydes and ketones we have taken. Here in cross aldol condensation we are taking different aldehydes. We are taking different aldehydes or ketones. So different aldehydes and ketones with are having at least one alpha hydrogen will react with base and forms the water total of 4 products we will get. Now what are the 4 products you see here? So it is acetaldehyde I am taking. So acetaldehyde react with propanaldehyde, CH3, CH2, C double bond OH. So these two are what? Different aldehyde. It is acetaldehyde. So it is propanaldehyde. Propanaldehyde. So acetaldehyde and propanaldehyde, when they react with a dilute base, then what happens? We are going to get total of 4 products. Out of 4 products, 2 will be self product, and 2 will be cross product. 2 will be cross products. So now you see in this case, just now I told you no trick. So based on the trick we will do. So now here only acetaldehyde is involved. Then what happens? We are getting the water self product, that is 1 product. Only propanaldehyde is involved, 1 more product, that is 2 will be water self product. So in cross aldol product, what happens in cross products? So one of the aldehyde will act as enolate, another aldehyde will act as electrophile. If it is acting as enolate means it will act as electrophile. If it is taken as enolate ion, it will act as electrophile. Like that we will get the 2 compounds. Now we will see self product first. In case of self product, so just now I told you self product how to write. Some simple trick we will follow. CH3, CH double bond O. Here what happens? Alpha carbon is this one. So same compound or same aldehyde we have to take, that is H2, CH, C double bond OH. Then what happens? These 2 will be removed as water molecule. So then what is left over? CH3, CH double bond, CH, C double bond OH. It is a simple trick to form the water self product. So for this compound, for that compound, CH2, CH double bond O. Aldehyde, CH double bond O. And here alpha carbon is this one. So that is H2C. This alpha carbon contains the water 1 CH3 group. So which is combined with water, which is bonded with aldehyde functional group. This oxygen and this hydrogen is lost as water molecule. Then what is left over here? CH3, CH2, CH double bond C, CH3. So C double bond OH. That is what self product. These 2 will be what? Self product. Now very important. 2 will be self product. Now we are going to see the cross product. So one will act as enolate ion, another one will act as electrophile. Now first you take this is CH3, CH double bond O. In this case H2, CCH3, C double bond OH. Now in this case what happens? So this oxygen and this hydrogen is lost as water molecule. So then what is left over? CH3, CH double bond C, CH3, C double bond OH. Now this is a cross product. Now in this case what happens? This hydrogen is, this alpha carbon containing hydrogens are removed. Now in this case we will take this alpha carbon containing hydrogens. So CH3, CH2, CH double bond O. Now in this case H2CH, C double bond OH. Now this acetaldehyde I am writing like this. So then what happens? It is removed as water molecule. Now we will get the, so CH3, CH2, CH double bond, here CH, C double bond OH. Now these 2 are what? Cross product. These 2 are cross product. So which is very important as a IPA point of view, that is board exam point of view, as well as for the competitive point of view. In cross aldol condensation we are getting total of 4 products. What are those? 2 will be self product, 2 will be cross product. You can apply by using the mechanism or by using simple trick. You can follow this method. Is that clear? Now we will see the self aldol condensation. Okay na? So intramolecular condensation we will see. Intramolecular aldol condensation. Within the molecule aldol condensation takes place. You see that within the molecule how aldol condensation takes place, we will see. Within the molecule, that is what we are calling intramolecular aldol condensation. Intramolecular aldol condensation. Now in this case, intramolecular aldol condensation. Now you are going to take the one compound here, CH2, CH2, C double bond OH, CH2, CH2, C double bond OH. When it is react with dilute sodium hydroxide, then what happens? We are going to get the intramolecular product. Now first it will form the enolate ion. No? Now you take it is enolate ion. Here one of the proton is lost as H plus ion. Then one proton is lost with base. Then this enolate ion will be attacked on this carbonyl carbon. So this carbonyl carbon converted to what? O minus. That H plus ion will attack here. Now you take the numbering from this. So from this carbon you take 1, 2, 3, 4, 5. So the bond is formed between 1 and 5. The bond is formed between 1 and 5. This is 1, 2, 3, 4, 5. Now this 1 and 5 we are getting the bond. Here at fifth carbon O minus, that is combined with OH. At first carbon what we have? C double bond OH is there. At first carbon we have C double bond OH. Now this is alpha carbon, this is beta carbon. So it is what? Beta hydroxyaldehyde, which is on further, which is upon heating, then what happens? Alpha beta unsaturated compound we are getting. This is alpha beta unsaturated carbonyl compound we are getting. Is that clear? Which is very important. Okay na? So this is what aldol condensation. We'll see some more example for this. Different example we'll take. Now you take this is cyclohexanone. When it is react with, which has the alpha hydrogen. So when we are taking 2 moles of cyclohexanone, when it is react with dilute sodium hydroxide, then what are the product you are going to get? So here you are getting the negative charge, 1 mole of ketone it is. Now another mole of ketone is this one, C double bond O. Now what happens? Which will be attack on this carbonyl carbon. So then this oxygen get the O minus. So C double bond O. So this you take is O minus, that H plus will combine. It is alpha carbon, it is beta carbon. So it is alpha beta hydroxy carbonyl compound we are getting. So which is on condensation, what happens? We are going to get the double bond between these two. OH. It is alpha beta hydroxy compound. Is that clear? So that is what we are calling. So aldol condensation in this case. You can take the another example also in case of aldol condensation. So different example. We'll take the another different example. One will be one with aldehyde, alpha hydrogen. Another one with without alpha hydrogen, C double bond OH. It is called furfural, which does not have the alpha hydrogen. You take this is a ketone, which has the water alpha hydrogen. So whenever it react with a dilute base, dilute OH minus ion, that is dilute sodium hydroxide or potassium carbonate or barium hydroxide. So then what happens? Which captures the proton from here. So which will be attacked on this carbonyl carbon. Then we are going to get, so COH it will be H. So in this case we are getting the compound. Now this is alpha carbon, this is beta carbon. So which is on condensation, we are going to get this compound. CH double bond O. Okay na? So this is alpha carbon, beta unsaturated compound, which is upon heating by loss of water molecule. Okay, so sorry, here it is a double bond O. Okay, in this case it is by loss of water molecule. Is that clear? So that is very important one. So you can take like that such type of example, you can take so many. Now you can take the another example also. One is benzaldehyde you take, another one is acetophenone you take. So last example I will explain in this aldol condensation. Like that you can take so many number of example here. So I am taking the acetal benzaldehyde. Without alpha hydrogen will act as electrophile, which act as electrophile. With alpha hydrogen containing acetophenone. This is alpha hydrogens which has, so whenever it react with sodium hydroxide, dilute sodium hydroxide, so we are going to get by loss of water molecule. First we will see the condensation, aldol reaction. So we are getting CH2 minus. This one will be attacked on this electrophile which act as nucleophile. So here CH, OH, CH2, C double bond O. Now it is alpha carbon, it is beta carbon, which is upon condensation, upon heating, by loss of water molecule we are getting the CH double bond, CH, C double bond O. Okay, na? So this is what main compound we are getting in condensation product. Now this all will be what examples, different example we have discussed. I think so you have got the complete information about aldol condensation. Okay, na? So this is what a complete video about aldol condensation with mechanism, with a simple trick. So if you really like the video, if you really like the content, you like the video, and please do subscribe and share with your friends. Thank you. Have a nice day. Keep watching Upper Chemistry classes.